Hi everyone, today we continue practicing OpenCascade in frames of our small console application. To remind you, we now have this small entry point, which is a main function, and what it does, it constructs a simple solid box using one of the OpenCascade's API tool classes. The result of modeling is then available in shape variable of TopODS shape type, which stands for topological data structure, and this is a basic type for all CAD primitives in OpenCascade. Our plan for today is to bring some 3D visualization to our empty exercise, and this way to make it way more exciting. There are quite some options for you to check when speaking about 3D visualization, because possibly you might want to stay focused on 3D modeling itself, and if so, you can prefer delegating all 3D visualization business to some external CAD package, like FreeCAD for example. And there are quite some libraries available out of the box which do a pretty amazing 3D visualization job. And one of such is OpenCascade Native Visualization Module, which is AIS, which stands for Application Interactive Services, and you might want to check it out. Personally, I prefer another solution, which is a VTK, and VTK stands for Visualization Toolkit. It's an open source scientific visualization library being developed by Quaoar, also known for their ParaView product, which is a pretty famous thing. If you're gonna get started with VTK, the first thing to do is to get to the official website of it, which is vtk.org, and download the official tarball with sources. In my case, the latest release is 9.0.1, so I download the tarball here, then unzip it, and then I have to configure it using CMake GUI. As usual in CMake, you have to specify the source and the build directories, and also to select the generator, which is one of the bundle generators provided by CMake itself. Once the configuration process completes, do not forget to check the values of your CMake variables. And one variable which is pretty important thing is this CMake install prefix. It's gonna contain your directory where VTK will be installed, so that it will contain all the libraries and DLLs and header files of your VTK installation. And later on you will use it in Visual Studio to configure your project. Another bunch of useful variables includes VTK group enable something. For example, if you want your VTK scene be rendered in Qt widget, make sure to turn on this VTK group enable Qt thing. So let's leave other CMake variables with their default values and just generate our Visual Studio project files. Then we can open up our IDE, and in Solution Explorer of Visual Studio we can find this specific project named install, and if you build this project, then VTK will not only get compiled, but all the outcome binaries will be copied to our installation directory. While VTK is being compiled, we can get the sources of OpenCascade on its official GitHub page. So our plan is to recompile OpenCascade and enable VTK support there. You go to GitHub and search for OpenCascade SAS. Once you are done, you configure OpenCascade with CMake GUI as well, and here, as usual, you specify source and build directories. And then again you have to select the generator, which is again Visual Studio 2019 x64. Do not be surprised that the first configuration attempt fails. That happens because CMake was not able to find third parties, which OpenCascade depends on. Unlike VTK, OpenCascade is not an independent thing, and you have to download and configure quite some third parties like FreeType, FreeImage, TCL and TK, to name a few. Fortunately, on my machine I have the whole bunch of these third parties, and if you do not, then you might want to check out one of the previous videos on our channel here. Once the configuration process is successfully done, you should also check out a couple of variables more. One of them is of course with install_dir. Here you type the destination directory where all the binaries of OpenCascade will be copied. And also, do not forget to enable this use VTK flag. it will bring VTK bridge to our OpenCascade delivery. Here in the Visual Studio with OpenCascade, we can do a couple of quick checks before we go and compile this whole thing. In the Solution Explorer under Modules, you see this visualization subfolder, and here you see this TK-IVTK project, which is our VTK bridge. So its very presence means that our VTK bridge is here and we can compile it. But before we compile, we have to choose also a good configuration, which is either release or debug, or it can also be release with debug symbols, and then we compile this whole solution using this install project. Now we can check that our IVTK package is operational, and for that let's start from draw.exe. We set it as a startup project, and that's basically an entry point to OpenCascade, so we can run debugger on it. So we start draw and you see this command terminal here, and basically here we type pload all as a first thing, because what we want to do now is to load all the plugins available in OpenCascade. Basically the IVTK bridge is an optional thing, and that's why we have to pload it specifically. So for that we have to type like pload VIS, where VIS stands for VTK Integration Services. Now we are good to go. We have all our IVTK commands available in our terminal window. So basically, in order to visualize something, we first create a box with dimensions of 1, 2, 3, and then we can check that it's a solid. So our A variable is a real 3D object which we can visualize. And in order to do so, in order to visualize it, we type VTK init and then IVTK display. And we have our box visualized in wireframe view. So we can use some other commands to tune the visualization mode of this scene, like we can switch to shading mode using this IVTK set disp mode and pass 1 there. And if you just type IVTK, you will see the whole list of IVTK commands right in the draw console. Okay, so let's finally return to our main function and try to have some VTK visualization code here eventually. But before we start, let's go to the project properties of our Hello OpenCascade, and I will show you which modification you have to take in order for the whole thing to compile on your machine. So first thing to check is VC C++, then general, and here you can notice that what I have now is this additional include directory for VTK, so that now I have not only the include directory for OpenCascade but also for VTK. Then for the linker options here, if you go to general, then what I have here is this VTK lib directory. And for OpenCascade, I have this libd, which stands for debug, because I have this configuration debug. And also for VTK, I do not have this d suffix here, because my VTK was compiled in debug mode, but it was installed into this lib folder. So make sure to not mix up debug and release configurations. Then in the input, you have to enumerate all the libraries which you are going to compile against. And here what I have, I will show you. Here is a full list of libraries, and you see that there are quite some libraries coming from VTK itself, like VTK interaction style, then version, then D, which stands for debug. In the release you will not have this suffix again. And also I've added a couple of libraries more from OpenCascade, including this TK-Math, then TKV3D for visualization, things like selection, and then of course this TK-IVTK, which stands for this our VTK bridge. So the one last thing to check here is this debugging setting, and here in the path variable I've added a couple of things as well. So here what we have here this VTK bin, where all my dynamic libraries, I mean DLLs, are located. Then also you will have to include this free type thing, because it's a runtime dependency of OpenCascade, and if you don't specify it here, you will not be able to run your executable. So finally, let's start programming. And in order to have something visualized, we will have to do some preparation job, like to allocate a couple of auxiliary classes, including render window, renderer, and all these things. So let's start from VTK Render Window. Basically what we need to have is this VTK Render Window. class, and if you check it precisely, you will discover that this is a as any other VTK object, this is something to be allocated from the heap memory, and that's why basically you should make it as a pointer. Let me call it like renwin, and then normally you can allocate it like this using this new directive here, but this is not generally a good way to go, because all VTK objects, they are supposed to be manipulated by smart pointers, just like objects from OpenCascade. So basically, let's start from including this class here with include statement. So we have it here, and you see that this code is perfectly valid. I think that Visual Studio complains that this constructor is basically not accessible, so that basically gives us a hint that we are doing something wrong. So what we can do and what we should do is to wrap this whole thing with VTK smart pointer, and this smart pointer syntax is a old schoolish VTK syntax which you should prefer to use whenever you are allocating some object from a heap. So it's going to be used like this. So you declare a smart pointer of the class you want to instantiate in the memory, and then you allocate it using this new static function, which should be called on the smart pointer, which is parameterized with your class name. This is one way which we can use, but it's a bit verbose. And to make our life a bit easier, what we can do is to use this VTK new instruction. This VTK new is basically a stack object which will live on a stack, and it will allocate your render window here right at this instruction, and then it goes out of scope. This render window will be automatically destroyed. So this is one thing to do. Then, in order to initialize our render window, we also need to create on what is called a renderer, and renderer is an object in VTK which controls how objects are rasterized, how they are visualized. So this is a VTK renderer. Let's call it simply ren, and then we initialize our render window with the renderer, like we say renwin set or add renderer, yes, and then we pass the renderer here. And we need to add a couple of things more in order to have our 3D scene initialized. Basically, what we need to have else is what is called interactor style. Interactor style is something to control your style of interaction, as you can guess from its name, like what will happen when you click a left mouse button, what will happen when you press some keyboard button. So basically it allows you to customize or to reuse some existing logic of interaction, or how it's called, interaction style. So let's have one. We go like VTK new, then VTK, let it be VTK interactor style trackball camera, which is kind of default thing. Interactor style trackball camera. Let's call it like iStyle, and this thing is something to include as well. So here we go, we have this interactor style. Then we also need to have interactor, which is a VTK new, then VTK render window interactor. So basically the things which I am writing right now you can find in almost any VTK example which you can search for in the internet. So let's call this thing like iRen. I'm not sure if we have to include this thing or not. It seems to be working as is. And for initialization of this render window interactor, what we have to do is to pass there a render window using this set render window method of it. It's going to be renwin here, and then we also have to initialize it with the interactor style. So it's going to be like iRen set interactor style, and here we pass our iStyle object. So finally, yes, Visual Studio complains that this object is not complete, so I have to go and include it here as well. Here we go, so we have our render window interactor now, and this set interactor style, it seems to be, so here I made a mistake, so this is something easy to fix. So basically what we have now this render window which is initialized with a renderer, which is a kind of a viewport in our render window. Then we have our interactor style initialized with a trackball camera style of interaction, and also our render window. So we are almost done. A couple of things more which we have to do. include basically rendering invocations themselves. So what I have to do, I have to call this renwin, then render to have my window, and then I also have to start this interaction using this start method of my render window interactor. Basically, that's a bare minimum of code which you need to have in order to initialize a VTK window in your executable, but that's not enough, because basically if you try to run it, you will shortly realize that some things do not work, or you have some strange VTK warnings. So I'm going just to show you how would you fix it and the things which you need to have right at the beginning when you start using VTK. So basically we have to initialize a couple of VTK modules, like to dynamically load them as far as I understand VTK. So what we have to do now is to add a couple of magic macro, and this macro go like VTK module init. First thing is a VTK rendering OpenGL2, and another thing to initialize is VTK interaction style. In order for this magic macro to be resolved by Visual Studio, you also have to include something called VTK auto init. So here we go. I'm pretty sure we can try to run this thing. So let's simply compile it now. Okay, I have another error saying that I'm trying to use this VTK renderer, which is not resolved. So basically I just need to go and include this thing also here. Renderer. So finally it compiles, and then if I hit F5 on my keyboard, what I see is that everything is being loaded at the first place. And then I see this black window, which is basically a 3D view, but it's not evident that it's a 3D view because we have no objects to visualize here. So let's have something here, and basically here, in order to visualize something with VTK, we need to understand the basic concept of a VTK pipeline. What is a VTK pipeline? So say you have some domain data, which is basically some data object of whatever nature, and in our case we are going to have like TopODS shape, which is an OpenCascade class. And then in order to use the VTK visualization, the first thing we need to do is to convert this domain data to polygonal data representation of VTK, which is a VTK polydata, which is a type provided by VTK itself. Here I need to say that it's not necessarily VTK polydata, because there are some other options in VTK, some other dataset types like VTK unstructured grid or VTK structured grid, and some other things like VTK image data, for example. But we will stick to this VTK polydata because we are going to use it, and because our shape is perfectly representable with a set of triangles and polylines. So this VTK polydata can undergo a set of filters, like they are called in VTK, or in other words, these are algorithms which convert your 3D data from one form to another. So we can say that's like a filter, then filter, then filter. So there is a sort of pipeline of filters which modify your data in some way, and at the end you have this mapper which maps your 3D primitives to OpenGL primitives, and at the very end you have the actor, which is something you can show on the scene, which something you add to the renderer for visualization. So here, in order to see something on the screen, we need first to have this VTK polydata. But before we have one, let's add this mapper and actor, because here, to create this mapper and actor, we do not need anything from OpenCascade. We can use just native VTK entities. So for VTK mapper, what we are going to have is VTK new VTK poly data mapper. This thing is of course something we have to include first. So let's do this, and let's call it like simply a mapper. And then we, in the same manner, we are going to create a VTK actor. So basically I have to initialize my actor with a mapper using this setMapper method. So what I am doing now is I'm establishing this link here between my actor and my mapper, and then I need to set input to my mapper in order to plug my shape somehow to this mapper. So what I'm missing right now is this link, and basically I'm not going to have any filters or algorithms to modify my data. So what I'm going to do now, I just need to create this simple or even simplest possible pipeline. We should also not forget to add this actor to a renderer at some point. So I have this rend, which stands for renderer, as you remember, and then I have to add actor to my renderer. So here we go. And the missing point here is to initialize my VTK polydata, like to have it at some point. For that I'm going to use this VTK package, which, if you remember, we enabled when we configured OpenCascade. So for that I'm going to create a shape data source, which is VTK new, then VTK tools. This time it's a package of OpenCascade, shape data source. Let's call it like OCC source. And this thing I should also include. So here we go. And basically what I need to do now, I need to initialize this OCC source with my shape. And if you remember, we have this shape as shape here. It's of type TopODS shape. If I look for the methods which are available here, I will find shortly that there is this setShape method, but actually it doesn't accept this TopODS shape type. It accepts something different, which is VTK OCC shape handle. In order to pass something meaningful here, what you need to pass actually is a wrapper, which is VTK OCC shape, because this is how this VTK component is designed. It doesn't accept the shape directly, it accepts some intermediate interface. So let's pass here a shape. And now we have our source initialized. And if you check this class here, you will find out that this is a native VTK class inheriting from VTK polydata algorithm, which is a perfect source in our terms of pipeline. So basically I can plug this VTK source to my mapper right away. So now I have this mapper, and what I can do, I can just set input connection or set input data, but I'm going to use set input connection because I have this source as an algorithm as well. And I'm going to pass here this OCC source and its get output port. That's a basic syntax of VTK. How would you compose a pipeline out of your algorithms? So let's compile this whole thing again and give it a shot. I press F5 as usual. And you see I have my box over here. And basically it's a combination of two display modes. It's both shading and wireframe all in one actor, because this data source which we just created, it contains both triangles and polylines to represent both shaded and wireframe view. So let's briefly sum up what we have learned today. Actually, we discussed that it's a good idea to separate your modeling code from 3D visualization front end, to say so, because a 3D visualization engine can be just anything. You can even prefer using some external software package to visualize your 3D data. And instead of that, we went and integrated VTK visualization to our exercise. So we can use VTK, and we compiled VTK from scratch. You should be careful about these CMake options which VTK exposes, and there are quite some options you might want to check out, like off-screen rendering, for example, if you want to produce some images out of your 3D modeling algorithms without showing any window to the users. Then OpenCascade, it comes with this VTK package, which is a sort of a bridge between TopODS data structures of OpenCascade and VTK polydata, which is a polygonal dataset, the simplest possible sort of unstructured surface polygonalization of whatever geometric object. When we wrote some C++ code to have IVTK package in action, we integrated VTK including this IVTK package. So we composed a simple pipeline for visualizing our 3D data, and we've seen that we can easily have some 3D scenes showing our modeling results without so much effort. So this is that. I hope this video was not too boring and you got enough information to start using 3D visualization in your code. Keep asking questions, and also if you have ideas what we should cover in the next lesson, then feel free to post a comment.